Today we're going to talk about reference angles and coterminal angles. So just a quick reminder, when you draw angles in standard position, you always put the initial ray along the positive x-axis. So for all three of these, always start with that initial ray along the positive x-axis. Then you use an arrow to indicate how far the angle is rotating. So here in this case, 305. It helps to maybe label these at first while you're getting used to them. We know that 305 lives somewhere between 270 and 360, so you don't have to be perfect, just have your arrow end up somewhere in that region. Then finally, the terminal ray is the ending side of the angle, so we will draw that terminal ray right here. So let's do the next two. Now notice this one is negative, so instead of going up, instead we're going to go down. Now again, this is negative 90 degrees, negative 180 degrees, because we're going backwards, negative 270. So we know that we're going to land somewhere in here. Doesn't have to be perfect, just make sure that you're in the right quadrant. So if you're in the top left, you're good to go. And then here is our terminal ray. And then for our last one, this one's in radians. That's okay. If we go backward, we know that this is negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So if we're going negative pi over 4, we know that's got to land somewhere in here. You might also remember from your unit circle that positive pi over 4 is the same as 45 degrees. So this is negative 45 degrees, just in radians. So here are angles in standard position. The reason we're reviewing that is because we are going to look at some pairs of angles. So let's start with 127. Now 127 lives between 90 and 180. So we're going to plot it right here. And then negative 233. So that lives somewhere between negative 90, negative 180, negative 270. Okay, so these angles are different. For sure, they're different numbers. But how are they similar? They both have the same ending ray. This ray right here and this ray right here are in the same position. They have the same terminal ray. What makes the angles different? Well, they're 360 degrees apart. Take your calculator real quick and do 127 and subtract a circle, subtract 360. You'll end up with negative 233, or you could go the other way around. You could do negative 233 and add a circle. You'll end up with 127. If you take an angle and you add a circle and add a circle, oh, it's making a circle for me, and add a circle and add a circle and add a circle, you can add as many 360s as you want and still end up in the same place. And the reverse is true too. You can subtract as many 360s as you want and still end up in the same place. Think about spinning around in your desk chair. If you face the front and you spin around and you're facing the front again, you're still in the same position. You've just added a circle. So what makes the angles different? They're 360 degrees apart. So how could you find additional angles that fit this description? You can add or subtract more circles. In other words, you can add or subtract more 360s. So these are called coterminal because they have the same terminal ray. So co means same. They have the same terminal ray. So two angles in standard position are considered coterminal if they share a terminal ray. So to end up in the same position, a ray must be rotated a full circle. That means you could add or subtract 360 degrees, or you could add or subtract 2 pi radians. So find a coterminal angle with 305 that's between negative 360 and 0. So to get in this range between negative 360 and 0, should we add a circle or subtract a circle? To get into this negative range, we have to subtract a circle. So let's do 305 degrees minus a circle, and that lands us on negative 55 degrees. Is negative 55 in that range? Yes, it is. So we are happy. Let's try this next one. Negative 225 between 360 and 720. How do we get into that range? Do we need to add a circle or subtract a circle? We need to add a circle. Oh, that should be 360. So negative 225 degrees plus a circle ends up being 135 degrees. Is that between 360 and 720? No. But that's okay because we're allowed to add another circle. We can add as many circles as we want. So 135 plus 360, that lands us on 495. Is that between 360 and 720 degrees? Yes, it is. So we're happy. All right, this last one says, find an angle coterminal with negative pi over 4 between negative 4 pi and negative 2 pi radians. So what do we do here? Adding and subtracting a circle, in this case, looks like using 2 pi radians. So we're going to start with negative pi over 4, and we are going to subtract a circle. So we're going to subtract 2 pi, and I'm going to put it over 1 so we can subtract our fractions. Now remember, to subtract fractions, your denominators have to match, and they don't right now, do they? We're sad. So what do? If we multiply this right side by 4 over 4, we can rewrite the problem as negative pi over 4 minus 8 pi over 4. And now we're happy because we can subtract. We keep our denominator, and we do the operation in our numerator. So negative pi minus 8 pi is negative 9 pi. And that fits our answer. It's between negative 4 pi and negative 2 pi, and we are happy. Oh, you can label that with radians if you'd like. So those are coterminal angles. Let's check some. Let's see, are the following pairs coterminal? So what we need to do is see if we add 360 to 45, will that give us 405? So we're asking a question. Is that 405? Yes, it is. So adding a circle got us there. So the answer is yes. Let's test out 120 and negative 130. We got to subtract. So 120, and it doesn't matter which one you start with. I'm just starting with the first one. Let's see if we can subtract 360. What do we end up with? Negative 240. Uh-oh, those are not coterminal angles. What about negative 90 and 630? So let's start with negative 90 degrees plus 360 degrees. That lands us on 270. So we don't know yet, to be honest, because we haven't gotten high enough to see if we could land on 630. So what do? We add another circle. So plus 360. Let's try that. Oops. And that equals 630 degrees. Yes. And then this last one, negative 30 degrees. Let's see if we add a circle to that. Will that get us where we want to go? That's 330 degrees. So that is a no because we wanted 350. We're not going to land on it. Okay. So the last type of angle we're going to talk about today is called a reference angle. And you can see we're already pretty close to the finish line. A reference angle is an angle that we refer to. They're easy to refer to. Reference, refer. So reference angles are always in the first quadrant. So reference angles are always, always, always going to live right here in the first quadrant. So they're either going to be between 0 and 90 degrees or 0 and pi over 2 radians. So to quickly find a reference angle, measure its distance from the x-axis. Another way to think about that is draw a triangle and measure the height. The height of it is always going to give you your reference angle. So let's do it. Let's start with 305 degrees. If we graph 305 degrees, we start with standard position and then we go around this way. And this is our angle in 305 degrees. So we want to know this right here. So you can even think about this as a triangle. And if we were to reflect that same triangle up in the first quadrant, what would the measure of it be? You need to know what this height is right here. So what is that height? Well, we know that if this is 305 and that this is 360, the distance between these two measures is 55 degrees. So when we reflect the triangle up, that distance is also going to be 55 degrees. Since you're finding the height of the triangle, you're either always going to use 360 or 0 over here and 180 over here. So the reference angle here is 55 degrees because it's easy to refer to in the first quadrant. It's the same angle, it's just between 0 and 90 degrees. Let's try another one, negative 225. If we were to graph that, that would live somewhere in here. So here's negative 225. So if we were to draw a triangle out of that and reflect it into the first quadrant, we want to ask ourselves, how tall is that angle? Well, here, to measure the height, we want to know how far it is from 180. So in this case, it's negative 180. That's okay either way. And this is negative 225. What is the distance between these two angles? Since you're measuring distance, it's positive, and so this is 45 degrees. And so if you reflect that over here, this is also going to be 45 degrees. So all you're doing is taking your angle and reflecting it into the first quadrant and finding how tall the triangle is to help you find that angle measure. All right, these last two are in radians, and then you're done. So this one right here is 8 pi over 7 radians. So we know that 7 pi over 7 radians is the same thing as pi. So we know that this is 7 pi over 7 radians. So another 1/7 of a pi is going to be right here. So if this is 7 pi over 7 and this is 8 pi over 7, how far away are they from each other? Pi over 7. So if we take this triangle right here and reflect it up into the first quadrant like this, if this distance right here is pi over 7, then so is this distance right here. So your reference angle is going to be pi over 7 radians. And then last but not least, this one's not too bad. This is negative pi over 4. So if this is your angle in standard position, we start here and we go down pi over 4. We know that's the same as 45 degrees from our unit circle. How far is this? Well, if this is 0 and this is negative pi over 4, the distance from here to here is positive pi over 4. So if we made a triangle here and we reflected that triangle up, that same reference angle would also be pi over 4 radians.